Hello, George Diamond here. Now today we're going to be doing video number 2 on the mean value theorem for derivatives. Now once again in our textbook, this is section 3.2. We use the Larson text and we're looking at the mean value theorem. Now in the first video we introduced the mean value theorem, we talked about it. Now today we're going to be looking at some applications of the mean value theorem. Now the mean value theorem says that the derivative, there should be some c value on a closed interval where the derivative at this x value is equal to the average derivative. That is the instantaneous rate of change. So if you look at my graph here, now the first problem we're going to look at here is f of x equals x squared over the closed interval from 0 to 2. Now this is what the graph looks like. So on the first problem here, we're going to sketch the graph. Now the other two problems, I'm not going to do the graph for those two, but okay, here we're going to start off with the graph. So when you start off with the graph, as you look at the graph here, okay, this indicates that the slope of I guess what would be the slope of our tangent line at a particular point on our curve, it has to equal the average rate of change. So the average rate of change, of change, okay, is going to equal the instantaneous rate of change. So the instantaneous rate of change. Now, so according to the mean value theorem, now this is what this indicates. So the instantaneous rate of change has to equal the average rate of change. That is, when you look at your curve here, okay, the instantaneous rate of change will be the slope of your tangent line. So this is the slope of the tangent line at point C is going to equal the slope of the chord. Now when you look at the graph, now here's the chord from here to here. Now, so what we're going to do is we're going to calculate the slope of the chord. Now there should be some place on this curve between 0 and 2, right, so on the closed interval, where if we draw a tangent line on that curve, the slope of that tangent line should be parallel to the slope of our chord. So there should be some place on here where if we were to draw the slope of a tangent line, it would be parallel to the slope of the chord. Okay, that means their slopes are going to be equal. Now remember, now derivative is slope. So as we set up our problem now, so we want to calculate the slope of our tangent line has to equal the slope of our chord, and we're going to calculate an x value somewhere between 0 and 2, right, where the slope of the tangent line is going to equal the slope of this chord. That is, the instantaneous rate of change will equal the average rate of change. So let me erase this right here and give me a little bit of room. Let's see how we set up our problem. Now, to begin with, let's get the derivative of our function. Now, the derivative here, f of x equals x squared. Now, the derivative is simply 2x. Now, so 2x is going to be equal to, okay, the slope of our chord. Now, this is f of b minus f of a over b minus a, and our endpoints are 0 and 2. So this will be the function at 2 minus the function at 0 over 2 minus 0. So this would be, so as we set up the slope of our chord, okay, this will be 2 squared, okay, minus 0 squared divided by 2 minus 0. So the function at 2 minus the function at 0 over 2 minus 0 has to equal the derivative. Now, solving this equation for x will give us that c value, right? So we end up here with 2x is equal to, this is 4 minus 0 divided by 2, so 4 over 2, or 2x is equal to 2. Now, to get our c value, all we do is finish solving this for x. So divide by 2, x is equal to 1. Right? So the c value here we're looking at, c should be equal to 1, and that's right here. So you come up to your curve, and right there on your curve should be the spot on the graph where if we were to draw a tangent line on the curve at that particular point, it would have the same slope as the chord between 0 and 2. So that's what we're getting now. When we get c equals 1, we're getting this x value between 0 and 2, where the slope of that tangent line is going to equal the slope of that chord. Right? This is the mean value theorem. Now you got to remember about the mean value theorem. Your curve has to be differentiable. That means it has to be continuous, okay, and differentiable. So no sharp corners or no sharp curves. It has to be smooth. It has to be a smooth curve. All right. So this is our first problem. So let me erase this one and let's take a look at problem number 2. All right, so we started off with a fairly easy problem, so this is pretty simple. All right, so let me erase this. All right, so it wasn't too bad. Okay, let's try a little bit harder example this time, so something a little bit more complicated. So problem number 2. Now number 2 I want to bring up here. I've already got it written down, so let me set problem number 2 up. Okay. Now this time let's try f of x equals 5 minus 4 over x over the interval from 1 to 4. Now, so let me write this down. So f of x equals 5 minus 4 over x over the interval from 1 to 4. All right, so this is our next problem. All right. Now, according to the mean value theorem, now remember, we're going to try to find some c value, so the derivative at c is going to equal the function at b minus the function at a divided by b minus a. So let's see if we can do the same thing again. This time we're going to try a little bit more complicated function this time. All right, so to begin with, now first thing we want to do kind of this in 2 parts. First of all, let's calculate our derivative, and then we're going to do the average rate of change. That'd be the slope of our chord. Set them equal to each other, then we have to solve for x. So let's see. Let's get our derivative first. Now our function here, we have f of x is equal to 5 minus, now 4 over x, I'm going to write that as 4 times x to the negative 1. So we're going to pull that 4 off, times x to the negative 1. Okay, now we can get our derivative. So the derivative, now the derivative of 5 is 0. The derivative of negative 4x to the negative 1 is positive 4x to the negative 2 power. So remember, you got to subtract 1 from your exponent when you take your derivative. Now this is equivalent to 4 over x squared. All right. Now this is our derivative. So that's the first part of our problem. Right? Find our derivative, 4 over x squared. So let me erase this. And it's going to put the derivative right here. So 4 over x squared is going to equal the average rate of change. Okay, now let's do the let's calculate the slope of our chord. So f of b minus f of a over b minus a. Now our interval here is 1 to 4. So let's see if we can calculate this part. And I'm going to set my problem off here. I'm going to kind of get it out of the way. So let's see what we get right here now. We've got 5 minus 4 over x, so this will equal, so 5 minus 4 over 4 minus, okay, 5 minus 4 over 1, okay, all this divided by, okay, 4 minus 1. Now, so once again, the function at 4 minus the function at a divided by 4 minus 1. All right. Now, let's see what we get. Now, let's simplify our slope of our chord, this expression here, and it's going to set it equal to our derivative, and then we're going to solve for x here. So as we simplify this, now this will be 4 over x squared is equal to, now this will be what, 5 minus 1, 5 minus 1, which is 4, minus 5 minus 4 is 1. Now 4 minus 1 on the bottom gives us what? Gives us 1. So we end up with 4 over x squared equals 1. Okay, now this is our derivative, so this will be our instantaneous rate of change is going to equal our average rate of change. Now the average rate of change is 1. Now 1 would be the slope of our chord from 1 to 4 on our curve. So when you look at the 1, that's what we're getting now. We're getting the slope of our chord, the average rate of change, that should be 1. And remember now, the derivative represents the slope of our tangent line. Now, let's solve this for x. So I'm going to start off here by multiplying x squared to both sides, multiply x squared here. And that gives us 4 equals x squared. You take the square root of both sides, it'll be plus or minus 2 equals x. So we have 2 x values. Now all we have to do is find the x value, right? We're just looking for the c value. What would be the c value? Now, you have plus or minus 2. Now immediately you got to recognize now, okay, negative 2 is outside the interval from 1 to 4. So the negative 2 we can discount. So it'd be 2 equals x, or c equals 2. So the c value, right, where if you were to draw a tangent line on the curve at x equal 2, right, it would equal, it would have a slope of 1. Right, so as you look at that problem, that's what that indicates. Right? So our c value or our x value, where the slope of our tangent line would equal the slope of our curve, would be when x is equal to 2. Now I'm not going to do that. I'm not going to do the graph of this one. We did the graph on the other one. But we'll try one more problem. Let's take a look at problem number 3. So do one more example. All right, so on that. Now this time let's try a radical function. Hi, let's try one more example. Let's try, we're looking at the mean value theorem, and we're going to see if we can calculate or find an x value on the interval here from 2 to 6. And this time we're going to try a little radical function. So f of x equals the square root of x minus 2. All right, so remember your mean value theorem now, f prime at c. Now the derivative at c indicates the instantaneous rate of change at a particular x value. And that's going to equal the function at b minus the function at a divided by b minus a. All right, now f of b minus f of a over b minus a, this is our average rate of change. So remember your instantaneous rate of change is going to equal your average rate of change. We're going to see if we can find what that x value is. Now there could be more than one x value, so we'll see what we get. Now to get started, first of all, let's go and get the derivative of our function first. So the derivative goes on the left-hand side of this expression here. All right, so let's get our derivative. Now this is f of x is equal to, this will be x minus 2 to the 1/2 power. Now finding your derivative, we're going to have to use the chain rule to get your derivative. Now we're going to do the outside part of the function, so bring the 1/2 down, leave the inside the way it is. Make sure you subtract 1 from your exponent and give us to the negative 1/2 power times 1. So the derivative of the outside, leave the inside the way it is, times the derivative of the inside. Now rewriting this will be equal to, let's see, we'll write this without the negative exponent. It will be 1 over 2 times x minus 2 to the positive 1/2 power. All right, so this is our derivative. Now let's take this expression, and then we set up our equation over here. This will be 1 over 2 times x minus 2 to the 1/2 power. Now that has to equal our average rate of change. Now let's see if we can calculate the average rate of change. And this will be the function at 6 minus the function at 2 divided by 6 minus 2. So let's see if we can, on this side, I'm going to go ahead and calculate the average rate of change. So let me erase this. Okay, now let's take the 6, plug it into our function for x. So we end up here with the square root of 6 minus 2, okay, minus the square root of, the a would be 2 minus 2, so 2 minus 2. All that divided by 6 minus 2, which is 4. Now, let's simplify that, then we'll set up the other side of our equation. Now, 6 minus 2 is 4, so we have a 2 minus 0 over 4, which will simplify to 1/2. So let's go ahead and put let's take the 1/2 and we'll put it in our equation right here. So now that sets up our equation. So remember now, your derivative represents your instantaneous rate of change. That would be the slope of our tangent line. And that's going to equal 1/2, which is the average rate of change. That's the slope of your chord. All right, let me erase this part right here. Okay, now the last thing we need to do is solve this equation for x. That's 2 fractions, so I'm just going to cross multiply, all right? So cross multiply here, 1 times 2 gives us 2. Cross multiply here gives us 2 times x minus 2 to the 1/2 power. Okay. Now, to solve this for x, we're going to have to, looks like we want to divide both sides by 2. That gives us 1 equal. Now, the 2's cancel. X minus 2 to the 1/2 power. All right, now to get rid of the 1/2 exponent, let's cube, or let's square the right-hand side. And we got to square the left-hand side also. So 1 squared gives us 1. Okay, when you square the square root, that just gives us the x minus 2. I don't need the parentheses anymore, just be x minus 2, or x is equal to 3. So that's the x value. The slope of your chord will equal the slope of your tangent line. So that would be c equals 3. Now one last thing I got to double check. Make sure that x value or that c value is within your interval. So the interval is from 2 to 6. 3 is inside our interval, so we're good. This is just another little radical example of using the mean value theorem to determine where the slope of your tangent line is going to equal the slope of your chord on your graph.